Right, so today let's have a discussion on TIFR, okay, and what all you need to prepare and how the preparation is different than CSIR. And trust me, the preparation of Tata Institute of Fundamental Research, TIFR or TIFR, whatever you like to call it, is very different than your NET exam, okay, and we'll look into it how. So just let me introduce, for those of you who do not know about TIFR or who want to know about TIFR, who have filled the form. The exam is on 10th of December this year, right? The exam is on 10th of December, and there are 40 questions in the paper, right? And each question carries 3 marks. It is a multiple choice question paper, 3 marks for a correct answer and -1 for incorrect answer. I mean negative answer. If you do not attempt the question, then you neither gain marks nor lose marks, right? Now, about Tata Institute of Fundamental Research, it's in Mumbai. It's an institute in Mumbai, a very prestigious institute. The faculty over there is amazing. A lot of good research. High-end, high cutting edge, you can say, research is done at that particular institute. They have a lot of collaborations with scientists abroad, and so the kind of research that is carried out over there is tremendous. Along with this, Tata Institute of Fundamental Research, which is in Bombay, we have JNCSR, these two institutes. One is JNCSR, that is Jawaharlal Center of Advanced Scientific Research. This is located in Mumbai. So these two institutes, JNCSR and TIFR, are doing very well in the science, research in sciences, basic sciences. They are doing much better than even IITs, many of the IITs, right? So these two institutes are the top-notch institutes for basic sciences, and IISER, as you might know, IISER is also a very good institute, right? So for JNCSR, you can clear JRF or GATE and go for the interview, right? For TIFR, you have to give the entrance exam, which is on 10th of December 2017, okay? That is a Sunday. Now, see, after you clear the entrance exam of Tata Institute of Fundamental Research, there is an interview, and as the interview, if you are attending the interview, interview is very you can say taxing. The interview is very taxing because they ask you a lot of questions, and they are very conceptual questions, okay? And the best part about the interview is that they won't just ask you about chemistry. They can ask you general aptitude questions in the interview itself. Like I haven't given the exam yet. Tata Institute of Fundamental Research, but my friend, he went for the interview, right? So when he went for the interview, to him they asked questions like if there are 3 kinds of glasses, in which cup or in which glass if you are pouring hot tea, in which of the 3 glasses will it cool the fastest? So they ask questions like these also, or they can ask you very basic questions. How will you distinguish between salt and sugar? So they can ask you anything. Okay, so these are the couple of questions or couple of examples that I'm giving you. That was asked to my friend. He cleared the interview. He's in TIFR. He went for the master's course. So he is currently in the 3rd year. Okay, and he is a very hardworking person. And at some point of time, even he wanted to quit TIFR because they make you work like hell. Okay, I'm not trying to demotivate you or something, but that's the truth. If you are in TIFR, you have to work really hard, right? And if they can make him cry, he was a very hardworking person. He's a very hardworking person. And if they can make him cry, then it is going to be very tough, even if you are really dedicated to your work, right? Not demotivating you again, but that's the reality, right? You have to work really hard once you are in TIFR. Okay, but again, like I told you, if you are in TIFR, if you're doing your master's course or your PhD in TIFR, you can take it from me, take a word from me that guaranteed you will be getting, either if you're doing masters, you will be getting a PhD abroad, or if you're doing your PhD, then definitely you are going to go to a good institute to do your postdoc. So that is a big advantage with these institutes, JNCSR and TIFR. Even though they are going to make you work really hard, but in the end you will be paid for your hard work, right? So anyway, okay, so now let's just discuss about how to prepare for the exam. I mean, you do not have the time to prepare for the exams, but what you need to focus on. So the first and the foremost thing you need to focus on if you're preparing for TIFR is spectroscopy. Okay, and why do you need to focus on spectroscopy? Because 10 questions from the last 2014, 2015, 2016, 2017, for the last 4 years, on an average 10 questions have been coming from spectroscopy alone. So you can imagine, out of the 40 questions, 10 questions are coming from spectroscopy. That means 25% of the paper is based on spectroscopy. So if your spectroscopy is good, you have a really good chance of cracking this particular exam. So focus on spectroscopy. First and foremost, focus on spectroscopy. And if you do not have that much time, then in spectroscopy, what particular thing you need to focus on? You need to focus on NMR, okay, specifically Proton Nmr, okay, Carbon 13 NMR, and DEPT, okay. It is a part of Carbon 13 NMR, but I am especially emphasizing on DEPT because a lot of questions have been asked based on DEPT. So Proton NMR, Carbon 13 NMR, DEPT, then mass. Definitely one question is going to come, one or more than one. Basic questions, okay. Now one good thing about TIFR is, see, in CSI net, I will say that whoever cracks the paper is a hard-working person, okay. Because to be very honest, conceptual questions are not asked in the net paper. The questions are not conceptual. I mean, the more you read, the more concepts you know, there's a better chance you will be able to crack the JRF exam or the net exam. So it all depends on how many concepts you have read, how much hard work are you doing, right? Because what I mean is that if you do a lot of concepts, they will ask you a direct question from the concept, okay. They will not make you think. If you know a particular concept, there will be a direct question on it and you can easily solve it. But when coming on to TIFR, the questions are very easy. The syllabus is, not the syllabus, but the kind of questions that are asked in TIFR exam, they are very limited. Okay, the topics from which the questions are picked are very limited. But the kind of questions that they ask are very conceptual. I mean, even if you have practiced that topic hundreds of times and you are not clear with the concept, you will not be able to solve that question. So the questions are easy, the topics are limited, but the questions are highly conceptual. So I think it will be a better achievement if you can clear the TIFR exam than your net exam. So because in the TIFR exam it's conceptual and your concept should be clear and you should be hardworking. Both are needed. But in JRF or net exam, you can actually clear the exam even if your concepts are not as great. Because if you have studied a lot of concepts, there will be a direct question, and you do not have to involve your mind a lot in the net exam. Yes, the competition is more, but I think the TIFR paper, the standard of the TIFR paper is much greater than your net paper. Anyway, so Proton Nmr, Carbon 13 Nmr, DEPT, mass. Then you have UV. These are the basic spectroscopies, right? NMR, mass, UV, and IR. So these you have to definitely do, and along with that you have to do some physical spectroscopy concepts. Like microwave or rotational spectroscopy, and vibrational. Microwave, vibrational, and Raman. If you do these concepts, I am not talking about the advanced concepts, only some basic things you should know about vibrational. I mean, which kind of molecules give vibrational, what is the Stokes line, what is the anti-Stokes line, and some very basic stuff. But you should know these concepts well. So if you are able to do these all spectroscopic techniques well, NMR and carbon 13, proton, mass, UV, IR, microwave, vibrational, and Raman, you are sure to, at least from the 10 questions, you will be surely able to solve 8 questions, right? So that will give you a big edge over the other aspirants. So practice spectroscopy really well. I am repeating again because 25% of the paper from the last 4 years, on an average, 25% of the paper has been asked from spectroscopy itself. Okay. Now let me check whether the video is filming or not. Right. The second thing you need to focus on is quantum chemistry. So again, unlike NET, in quantum chemistry, in the TIFR, you will not see questions based on perturbation variation theorem. You will only see questions based on the chapter of very basic quantum mechanics. For example, questions will be there on the you can say the wave function. What kind of wave function can be used? I mean, the conditions for the wave function. It should be a continuous function. There are 6 or 7 postulates of quantum mechanics. You have to understand those concepts of quantum mechanics. Only the basic first, second chapter, not the perturbation, variation, tunneling. You should not. You are not. You should not focus on that particular topic. In the NET exam, yes, perturbation and all do come, but in TIFR only very basic questions from quantum chemistry are asked, right? For example, out of these 4 functions, which of the functions is not a continuous function, for example. So you'll be given a lot of examples. Or which of the functions is not single valued? Questions like these, very simple quantum mechanics questions from the introductory part of the quantum mechanics. I mean, the postulates of quantum mechanics, Hermitian operators, Hamiltonian, what is a Hamiltonian? Questions based on the very basic concepts of quantum mechanics are asked. Okay, and along with this, quantum chemistry, solid state, many questions, again 4 to 5 you can say, or let's say 3 to 4 questions are asked from solid state. Actually, not even 3 to 4, at least 5 questions are asked from solid state again. And the questions are from first of all Bragg's law. Okay, then the percentage. The questions will be based on FCC, BCC, and SC crystal lattice. I mean, they are packing fractions, and questions related to basic questions that are asked from Bragg's law. I mean, from solid state, this formula D equal to Zm by A cube Na. Numericals can come on this particular formula where D is the density, M is the molecular weight, A is the side length of the lattice of the cube, and Na is the Avogadro number. So this basic formula which we have studied in I think 11th or 12th class. Based on this, numericals can come in the exam, and along with that, defects. This is very important. Why is it not working? Defects. Practice defects really well. Frenkel, Schottky defects. Then questions will come on doping, okay, or on band gap. Band gap in semiconductors, band gap in solids, band gap in insulators. Then questions on doping, N-type semiconductor, P-type semiconductor. These questions will be asked, and these come in the topic of solid state. Okay. Then question on solid state can also be based on XRD. Okay, they'll give you an XRD pattern and they'll ask you, what kind of a lattice is that, FCC, BCC, or SC. I mean, this part of the course I have not done in my videos. I actually cover them in my personal coaching classes, and it is actually a very important topic. Okay, yeah, from NET point of view as well. Okay, so we have quantum chemistry, solid state, and these are the short topics I am telling you from where the questions are going to come, right? And I am going in the particular order. For example, spectroscopy 10 questions, solid state 5 questions, quantum chemistry around 3 questions. So we are done with 18 questions. Okay. Then we have thermodynamics. Thermodynamics. Again, 3 to 4 questions you can say from thermodynamics. I mean, in NET exam, questions from thermodynamics are more based on the entropy, that is the second and third law of thermodynamics, whereas most of the questions from TIFR are based on the basic first law of thermodynamics. I mean, the questions are not related to entropy as such, and numericals are not asked from thermodynamics as much as they are asked in net. I mean, net and gate, there are a lot of numericals based on thermodynamics, whereas in TIFR, what I have observed by looking at the previous year question papers is that many questions are asked based on the concept of thermodynamics. I mean, like delta mix greater than 0, less than 0. I mean, questions will be there testing your concept, not numericals. I mean, the numerical kind of questions of thermodynamics are going to be less. Then you have basic questions from kinetics, okay, and electrochemistry. One electrochemistry, definitely every year a question from electrochemistry is there, 1 or 2 questions, and not very tough questions. If you can just practice few numericals. If you are not practicing electrochemistry, you can just go through Puri, Sharma and Pathania or TL Kapoor and just practice some numericals. There will definitely be a numerical based on electrochemistry. Along with that, there are many questions on DNA, RNA, which I suppose you can leave out. Okay, not many questions. I mean, a couple of questions are there based on the DNA, RNA concept, and you can leave that out. Okay, I don't think you should study particularly for that, because you do not know what kind of questions might be asked in the exam. Okay, so you can leave out that topic. If you know that particular question, well and good, but no need to prepare for it, especially because see, most of these topics that I have covered till now, they will be asked in the net exam as well, and the net exam is just after a week. This exam is on 10th and the net exam is on 17th, right? So you should not deviate your focus. Your primary focus should be net, your GRF, because if you crack GRF, you have the opportunity to apply to any institute, right? TIFR is only reserved for TIFR. I mean, if you qualify TIFR, then also there is an interview, and the interview is really tough. Okay, so cracking the entrance exam is one part of approaching TIFR. But if you crack GRF, you have almost all institutes available to choose from, right? So your main focus should again be there on GRF itself. TIFR is coming before the net exam, so there are particular things you need to focus more for TIFR. Like I told you, spectroscopy, you have to focus on TIFR, and in quantum chemistry, the introductory part of quantum chemistry, you need to focus on. Along with that, pay more attention to solid state, thermodynamics, kinetics, electrochemistry. Kinetics you can leave out. Whatever you are preparing for GRF, that is good enough. Electrochemistry also, whatever you are preparing for GRF, that is good enough. What I want to suggest is that one numerical is definitely going to come from electrochemistry, so watch out for that. And okay, let me check first where the video is filming. Right, so one numerical that I have seen in all questions, in all question papers, 1 or 2 numericals are based on the calculation of pH. Definitely do this topic. Okay, this will fetch you 6 or 3 marks for free. So do this topic really well, calculation of pH. Okay, this question is definitely coming in the exam, calculation of pH. Of pH of a solution. They can give you anything. Numericals, you will see a lot of numericals based on this concept, where they'll tell you to calculate the pH. Okay, and along with that, 2 questions definitely are there from group theory, and mostly they are on finding out the point group. Okay, and generally they are very complex molecules, but they give you the structure of that complex molecule, so you should be able to find out the point groups of molecules. And one question that I can remember is Fe2CO9. There was a question based on Fe2CO9. So it is very difficult actually to calculate the point group of this particular molecule, because you have to look at the 3D structure of Fe2CO9. So if I draw the structure of Fe2CO9, Fe, we have CO, 3 zeros, right? There's the Fe bond. There are 3 bridged CO groups. Okay, and one of them is actually below the plane, and then we have 3 CO like this. Okay, So if you look at the structure, imagine this to be Fe, one Fe on the top, one Fe on the bottom. We have three CO groups. Like in NH3, it is a pyramidal structure, right? Where imagine this to be nitrogen, and we have three hydrogens like this, right? Similarly, over here also we have three CO groups, and here also we have three CO groups, and along with that we have three bridge CO groups like this. If I show you like this, so three COs are on top at an angle of 120, three COs on the bottom at an angle of 120. This is Fe, this is Fe, and along with that we have bridge CO. So bridge CO is like at an angle of 120, like this, or like this. Okay. So there are three CO groups. Now, if you rotate it by if you rotate this by 120 degree, you will get the same configuration. So it has a C3 axis. Along with that, it also has a C2 axis, because if you take this axis, this one, and you rotate it by 180 degree, you will get the same molecule, because there are three COs over here and three COs over there. So if you rotate it by 180 degree, you will get the same kind of configuration. So it has three C2 axis as well. So and if you cut it along this plane, your C3 axis is this, your principal axis is this, the C3 axis, right? And if you cut it like this, you will get a plane which is perpendicular. So you will have a plane of symmetry which is perpendicular to the principal axis. So the point group is D3H or Fe2CO9. So the questions will definitely be there from group theory as well. Okay. Lastly, there will be a question, there are 3 or 4 questions based on high school mathematics, that are 11th, 10th, 12th class mathematics. Not very tough, but the trigonometry, definitely there is going to be a question based on trigonometry, and there are questions based on logarithm, log e, log x, natural log. So if your maths, matrices and determinants, so if your maths is, if you are in touch with your maths, or if you had maths in 11th and 12th class, there will be also questions on probability. You know, it will look like a biological question, but it will actually be a probability question which you can solve by simple mathematics. So never give up on a question. If you think that question is like based on biology, do not give up on that question. Just read it once and see what kind of concept is being applied in that particular paper, in that particular question, right? So if you are still in touch with your maths, if your maths is good, then you have a big advantage over the other aspirants. And see, maths is one subject, even if you are not from a mathematical background, maths is one subject you should always be in touch with. Okay, for me, maths is very important. Not every day, but in a week I do practice some 12th and 11th NCERT questions. So it helps you in 2 ways. It keeps your mind sharp, and whatever good, whenever you are, first of all, it keeps your mind sharp, and you will require maths throughout your life if you are wanting to become a scientist. Even if you are an organic chemist, right? Even then, at some point of time, you will require maths. You will require a good amount of maths. Concepts from mathematics. So always be in touch with mathematics, and whenever you have the opportunity to do some calculation, never make use of the calculator. Okay, like anything, you are going for grocery shopping, you are going to buy something, whatever it may be, try and not use your calculator. Okay, because once you do the calculations, it keeps your mind sharp, and these are small things that matter a lot. So this is my suggestion, that never use a calculator for some basic calculations. I have seen people nowadays, or students nowadays, even for very simple mathematical calculations, they take out a calculator. It's a very bad habit, and you should not cultivate that kind of habit in you. Okay, right. So what else? You can do peptide chemistry well, especially calculation of isoelectronic point. Do that pretty well. Peptides, isoelectronic point. So that is one topic I missed out. So you have to do the isoelectronic point of proteins. Okay, and there are certain things in peptide chemistry that you need to figure out. For example, Zwitter ion, what is the zwitterion. Then remember the structures of various proteins and their short forms. It's not protein, sorry, amino acids. Do the structures of the amino acids and their short form. I mean their one letter abbreviation. Every amino acid, I mean the essential amino acids 21 or 22 have some abbreviations, like W is for tryptophan, something like that. So you should always you should know the shorthand notations of these amino acids along with their structure. It will not take you more than 1 hour at least. Maximum of 1 hour it will take for you to memorize those structures. So memorizing those structures specifically, especially for the TIFR exam, is very important. Okay, and I think that's it. So yep, that's it. All the best.